Good afternoon. This is Naveena from the Department of Cybersecurity in the Institute of Aeronautical Engineering, Dundigal. And in my last videos, I have discussed many routing algorithms by means of distance vector routing algorithms and the tables which are associated to solve the distance vector algorithm, and how the tables it will be maintained by means of a hoping the distance calculated, the hoping the distance when we can able to transmit or travel one packet from one sender to the receiver. And I came today by means of a link state routing algorithm, which would be a part of routing algorithms. And mainly the routing algorithms we should be classified by means of two types. The first one is the distance vector algorithm. Second one is the link state routing algorithm. As I have already discussed in my previous video about the distance vector algorithm and what are the advantages of the distance vector algorithm, disadvantages of the distance vector routing algorithm by means of several examples. And today I came with link state routing algorithm under the main type of algorithms which we can call it as a routing algorithms in computer networks. Link state routing has two phases. What do you mean by a link state routing algorithm? Means it is a type of routing algorithm which directly follows our discussion for creating the least cost trees, which are meant for creating the least cost trees, and forwarding the tables is link state. What we will call it as a link state, as we have already named today. And by means of a concept video, the name it will reflects or seems link state. Link state routing. This method uses the term link state to define the characteristic of a link. That link, what we can call it as an edge. The link, what we can call it as an edge, which represents a network in the internet. In this algorithm, the cost will be associated with an edge defines the state of the link. Links with lower cost are preferred to links with the higher cost. If the cost of a link is infinity, it means that the link does not exist or it has not been broken. This is the main concept. If you want to discuss about that link state routing algorithm, mainly it is used for creating least cost trees, and forwarding tables is link state, what we can call it as a LS routing. In the small way or a least way, what we can call it as a link state routing or LS routing algorithm. LS routing algorithm. So coming to this, a link state routing has two phases. So what are those two phases? Reliable flooding initial state. That means each node knows the cost of its neighbors. Second one is the final state. First is the initial state. Second one is the final state. So in the initial stage, which each node knows the cost of its neighbors. So coming to that final state, each node knows the entire graph which is meant for the route calculation. Each node uses Dirac algorithm on the graph to calculate the optimal routes to all nodes. And anyhow, the link state algorithm is also known as Dirac algorithm. The other name for the link state algorithm is Dirac algorithm or LS algorithm, which is used to find the shortest path from one node to every another node in the network. Again, the Dirac algorithm is an iterative, and it has the property that after kth iteration, that means n number of iterations it will be done. One iteration, second iteration, and third iteration, fourth iteration, and fifth iteration. Like the k iterations or n iterations, it would be over. So the least cost paths are well known for k destination nodes. The least cost paths are well known for the k destination nodes. That means out of all the iterations, the path will be selected out of many iterations. So after the completion of all the iterations, the last destination nodes will be determined. This is the main concept which should be included by means of link state routing algorithm, and it is also known as Dirac algorithm, which is used to find the shortest path for the transmission or sending the packets from one node to the every other node in the network, from one node to the every other node in the network. So coming to this is one of the example as I have want to explain deeply, and here it is one of the subnet of the network according to this one. So consisting of, there should be, if you can identify, 6 nodes will be there. The node A, node B, node C, node D, node E, node F. And out of this one, they should be having link 1, link 2, link 3. And again, B and D will be connected by link 2. D and C will be connected by means of a link 3. And C and D will be connected by means of a link 1. D and E will be connected by means of a link 1. So, and C and F by means of a 5. And this is the root by means of a 1. This is the root E and F by means of a 2. This is one of the exemplary diagram or the pictorial representation to illustrate the link state routing algorithm. So here, link state routing algorithm using a routing protocol to collect the whole network topology. That means link state routing algorithm is useful to collect the whole network by means of a total topology. That means if you can take the example of this one, it is nothing but the network topology to collect all the networks and the links which should be associated in between one network topology. If you want to identify it, it will be by means of a link state routing algorithm. And second one is, it obtains the destination reachability information as well as link weights states. And actually it will define or determine the destination reachability of the packets information, as well as by means of the one link it will be connected from one node to the another node. How many packets they can able to reach to the successive destination by means of connecting with the link associated from one node to the another node. And third point coming, if you want to discuss, compute shortest path using disject algorithm from node 1 to another nodes. Node 1 to another nodes. That means node 2, node 3 and node 4, or from one node to the another node. Simply in a networks language, if you are discussing, it is meant for to compute the shortest path using by means of a link state algorithm or a disject algorithm from a one node to all the other nodes. And coming to the last point, construct routing tables which shows the destination addresses and the next hop addresses. Always, and as according to my previous video, as I have already clearly explained, mentioned, based on the routing table, a routing table consisting of the addresses and the hop addresses and the reaching addresses and the destination addresses, or sending addresses and the destination addresses. A routing table consisting of two addresses. The first one is the base address or a sending address, and second one is the hop address, that is nothing but the destination addresses. So after that, when the last point is, note that when disject algorithm gives you an end-to-end routes, the routing tables may only store the next hop of the information parallelly associated with the links which will be by means of a one node to the another node it will be connected. So this is the applications or the tasks which should be performed by means of a link state routing algorithm while you are working in computer networks. So coming to this, one of the example, as I have already explained, by means of the network topology of subnet of different nodes, let's describe some notations. The C of ij link cost, C of ij will be the link cost, if you can assume, the link cost from node I to node j. The link cost from node I to node j. And if I and j nodes are not directly linked, then C of ij is equal to infinity. If the node I to j is directly linked, it will have a need to send their packets from the node I and receives that packets by means of a node j. Or else, if the node I and j, they will not directly linked. That means this will be total infinity. Suppose D of V defines the cost of the path from source to destination V that has the least cost currently. If you can take the equation part of one terminology, one term, D of V, it defines the cost of a path from one source to the destination while sending the packets from one node to the another node. V has been defined that the least cost currently, the path on which the packet it will be sending from one node to the another node. Coming to the second term in the equation, P of V, it defines the previous node. D of V is nothing but defines the cost of path. P of V defines the previous node. That means the neighboring of the V along with the current least path from source to V. So coming to that, the term N, it is the total number of nodes which are available in the total network. That means in our given example, this is nothing but N, N1, N2. These are the nodes which should be determined or described while you are talking or working with network topology in computer networks. These are all the nodes. This is the one network or subnetwork or network topology. So these are all the some notations, and I want to recollect again C of Ij. That means these are all the two nodes. If you can take the example of two nodes Ij, if they can collect it or link it directly, the packet can able to transmit from one node to the another node. Or if there is no link directly in between the any two nodes, one from the source node or one from the destination node, so that path what we can call it as infinity. That path what we can call it as infinity. So coming to the second notation, simply defines the cost of the path from one source to the another destination. Coming to the P of V, it defines the previous node. When you are working with the existing node, it defines the previous node. If you are talking or working on the previous neighboring node or existing node, it defines the previous node. It defines the previous node. So, neighbor of V along with the current least path from source to the V. So, N already defined the total number of nodes which will be present on the total network topology what you have currently dealing. So, coming to that, an algorithm initialization, if you can take the example, N is equal to the node of A. The A is a root node. For all the nodes, if V adjacent to A, then D of V is equal to C A of V, else D of V infinity loop find W not in N such that D of W is a minimum. That means if you want to add W to N nodes of updated subnet or network, the D of V for all V adjacent to W and not in N, D of V is equal to minimum D of V and D of W plus C of WV until all nodes in N. Suppose in the above algorithm, an initialization step is followed by means of a loop, and the number of times the loop is executed is equal to the total number of nodes available in the network. That means the number of times the loop is executed is equal to number of nodes. Number of nodes available in the network is equal to the number of loops will be executed. The number of loops will be executed is equal to number of nodes which are present in the network. This is nothing but the algorithm initialization, and which can define the A is a root node. For all the nodes V, if V adjacent to A, then D of V will be calculated as C of AV, or else D of V is equal to infinity loop. D of V is equal to infinity loop. So, this is nothing but the algorithm initialization. So, according to our previous algorithm, and if you can take in a stepwise, the step one is, the first step is an initialization step. The first step is a initialization step. The currently known least path from A to its directly attached neighbors B, C, D are 2, 5, 1 respectively. That means if you are taking the example, the current root node is this one. Will be considered as a root node and B, D, C are the neighboring nodes. These are considering as a neighboring nodes. So from the D, the E will be extended. From the E, C will be extended. From the C, F will be extended. From the F, E will be extended. So like that only, the first step is an initialization step. The currently known least cost path from A will be as a root node. A will be as a root node which is directly attached neighbors of B and C and D are 2, 5, 1 respectively. 2, 5, 1 respectively. The cost from A to B, is set 2. From A to D is set 1. And from A to C is set 5. The cost from A to E and F are set to infinity as they are not directly linked to A. Why? Because the E and F are not directly linked to the root node of A, as you have observed here. From the root node and B, D, C are extended or attached. From the C, E and F they will be extended. So hence, according to the algorithm initialization, so we can able to define the paths of A to B and A to B to C and A to D. From the C, C to E, E to F or C to F and E to F we can able to calculate. So that is the main task or the main theme of initialization steps. The first step, as I already discussed, and coming to that one, the cost from A to B is set 2, if you can think, and the cost from A to D is set 1, and from A to 5 is a 5. The cost from A to E and F are set to infinity. Why? Because as they are not directly linked with the root node of A. So hence, the step N means the number of nodes. N means the number of nodes. That means D of B and P of B and D of C, P of C, D of D, P of D, D of E, P of E, D of F, P of F. That means 1 A and 2 is A, 5 is equal to A and 1 of A is infinity. Coming to that step 2. This is the part of all I have explained based on the initialization under the part of step 1. The initialization steps under the part of 1 we have already discussed. Coming to the step 2 of initialization process of linked state routing algorithm. In the above table, we observe that vertex D contains the least cost path out of many nodes. The vertex D contains the least cost path in step 1. This one. This node can able to define or identify the least cost path. Therefore, it is added in N. Now, we need to determine a least cost path through D vertex. Hence, it can able to define, we observe that it wants to define the least cost path by means of a through D vertex. So, if you can calculate the shortest path from A to B, and what is the use of these type of algorithms to determine or to define the routing type of algorithms means to minimize or to determine the least cost path or shortest path which are able, one packet can able to travel from one source to the another destination. For that sake only, these type of algorithms will be determined or introduced. So, by means of the given examples, calculating short path from A to B, V is equal to B and W is equal to D. So, D of B, if you can take D of B is equal to minimum D of B and D of D plus C of DB. As I already explained, the A, it will be B, directly connected root node, and it will be associated with B, C connected, and D nodes. So D of B is equal to minimum D of B, and D of D, and C of D and C of B is equal to minimum 2, and 1 plus 2 is greater than, is equal to minimum 2, and here 1 plus 2 is equal to 3. Hence, at finally the minimum value is 2. Therefore, the currently shortest path from A to B is 2. So, by this way, we need to determine the very least cost path or the shortest path by means of a link state routing algorithm, or the other name of a link state routing, what we can call it as a Dirac algorithm. By only we can able to identify the currently shortest path from one node to the another node. According to our given example, if you can taken from A to B, is the minimum path is 2. So, coming to this and calculating the shortest path from A to C, we need to calculate the paths like according to the given example. From A to B, we need to calculate, from B to C, from B to D, and from C to D, and from D to E, and from C to F, and from C to E, and from E to F. We need to calculate for every one node to the another node, and how many links it will be associated by means of a one root node, and how many the second part of links which are associated with the other type of the nodes which are attached to the root node. We need to calculate the paths one by one extended from the root node only. So here, calculating the shortest path from the root node to the C. Root node to the C. That means A, B, C, D. And we can able to calculate A to B over here A to C. So V is equal to C. So W is equal to D. V is already defined. It is nothing but set of a least cost paths, and it is used to define the cost of a path while traveling one data packet from one source to the another destination. So here, D is equal to, D of B is equal to minimum D of C and D of D. That means D of B is equal to minimum D of C and D of D, and again D of C. C of D of C, we need to calculate that D of B. D of B, we need to calculate, again we have to minimize it, minimum D of C, again D of D and D of C is equal to minimum 5. If you can take an A to C, the path is 5, and minimum 5, then 1 plus 3 plus 4 is equal to minimum 5, and 1 plus 3 is equal to 4, and 5, the minimum value is 4. Therefore, the currently shortest path from A to C, if you want to calculate, it is nothing but the minimum value is 4. The minimum value is 4. The minimum value of the least cost path or the shortest path in between the root node of A to C is nothing but the 4. And A to B is 2. Here it is 4. Coming to this, calculating the shortest path from A to E. So, from root node to A to B, from root node to C, from root node to D, we have already seen, and the roots, it will be directly linked with root node to the subnodes. Coming to that, and the extended E and F, those are all the subnodes which are associated with B, C and D. So, B, C and D are the direct links or the direct nodes which are associated with the root node, whereas the E and F, those are all extended roots or linked paths by means of a C and D. If you want to calculate the shortest path from A to E, so hence here is the example, V is equal to E, W is equal to D. Here, D of B is equal to minimum D of E and D of D and C of DE. Suppose if you want to take A to E, according to the given example, and if you can take the given example already drawing, if you can go through that one, A to E, now they are calculating. A to E. In between the A to E, you want to calculate A to D, D to A. And D is connected again with the C. D is connected with the B. And B is connected with the C. C is connected with the E. So, like this only, if you want to calculate the shortest path from A to E, or if you want to count the least path from A to E, V is equal to E, W is equal to D, the D of B is equal to minimum, the D of E, D of D plus C of D E is equal to 3, minimum infinity and 1 plus 1. So, minimum is equal to infinity and 1 plus 1 is equal to 2. Hence, the minimum value is, one is the infinity, second one is the 2. So, infinity doesn't have any value. So, the 2 will be calculated as the minimum path or a short cost path or a least cost path from the root node A to the node E. Therefore, currently the shortest path from A to E is 2. A to E is 2. Here, again, the vertex D has no direct link to vertex A. It doesn't hold the direct link from root node to the E node. That means A to E doesn't have the direct node and it will be coming with the D to E. D to E. So, therefore, the value of D of F is infinity. Why? Because the D is having again the collection B. B is again the collection with the C and C is again with the E. So, like that only, if you want to take the example, if you want to calculate A to E. So, this is the root node and this is the sub node. So, therefore, the value of D of F is infinity. How means step N, D of B and P of B and D of C, P of C, D of D and P of D, D of E, P of E, D of F, P of F. Hence, the root node A2 and the root node A25, the root node A21, A of infinity, infinity. Hence, AD 2 and A4 D, D of infinity. So, hence, in the above table, we observe that both E and B have the least cost path in step 2. Let's consider the E vertex. Now, we can determine the least cost path of remaining vertices through the root node of A, from A to E and from starting to the ending or from ending to the starting. Like means, from A to E, we need to calculate, or from E to A, we need to calculate in a proposed way. This is one of the initialization steps to calculate the main nodes which are associated by means of a under one network topology. How many nodes it will be connected and how many types of links which will be associated to a one root node and how many links or the nodes it will be extended by means of the first section of nodes we have already initialized by means of several steps. Next, if you want to calculating the shortest path from A to F according to the given network topology, the V is equal to F and W is equal to E. So, hence, if you want to determine D of B is equal to minimum D of F and D of E plus C of E F is equal to minimum infinity 2 plus 2. So, it is equal to 4. Minimum infinity doesn't hold any value, hence the least cost path rate is 4. The minimum value is 4, therefore the current shortest path from A to F is 4. A to F is 4. So, here and again I want to discuss based on the diagram Again, we have already discussed about, and we have already determined the cost of path between the nodes which are associated. As I have already discussed, this is the root node and it is having associated with the root node B. From the root node, the B, and from the root node to the D, B to C, and B to D, C to D, and D to E, and C to E, and C to F. So again, we have already determined these two, B, D, are the direct nodes or the direct links which could be associated with the root node A. So coming to the C is extended node, E is extended node from the D. Again, F is a extended node from C to E. So, as we have already determined by means of this disject algorithm or link state algorithm, we already determined for each and every link and for each and every nodes between one node to the another node, we have already identified and determined the smallest cost path or the least cost path which a packet can able to travel from one source to the another destination. So coming to this, why you are dealing and why you are giving the most important by means of a disject algorithm, the link state algorithm means, and it will be holding some advantages parallelly, some disadvantages will be there. So coming to this, the advantages, if you are talking between the link state routing algorithm, the advantages of a link state routing protocol or the algorithm are, in our language, in the smaller way, if you can talk, it will be otherwise call it as a disject algorithm or as follows. The first one is the fast network convergence. That means it is the main advantage of the link state routing protocol because of receiving an LSP. That means link state routing protocol. Link state routing protocol. This is abbreviated as a link state routing protocol. Immediately flood the LSPs out of all interfaces without any changes except for the interface from which the LSP was received. Coming to this, the second advantages of a link state routing algorithm, topological map. The link state routing uses a topological map or SPF tree for creating the network topology. SPF tree is meant for creating the network topology. So using this SPF tree, each router can separately determine the shortest path to every network from one node to the another node when a packet wants to travel from one node to the another node to reach its successive destination. So coming to this, the third advantage of a link state routing algorithm is nothing but hierarchical design. As I have already explained about the advantages and how to calculate the least cost path or the shortest path by means of a link state routing algorithm or the disject algorithm, and a link state routing protocols use multiple areas and create a hierarchical design to network areas. These multiple areas allow better route of summarization, better route for the summarization. So coming to the last but one, the advantage of a link state routing algorithm or the disject algorithm, event driven updates. After initially flooding of LSPs means link state routing protocol, the LSPs are sent only when there is a change in the topology and contain only the information regarding that change. Whenever there should be any change, it will be occurring by means of a regarding the nature of the change, it will give the updates. Hence the name it comes like in the mode of event driven updates. So coming to this, the LSP contains only the information about the affected link. The link state never sends periodic updates. The link state never sends periodic updates. The link state never sends periodic updates. So coming to this, the disadvantages of a link state routing algorithm. So as we have discussed based on the advantages of a link state routing algorithm or the disject algorithm. Coming to the disadvantages of a link state or disject algorithm, link state or disject algorithm. So these are some of the disadvantages. The first one is the memory requirement, second one is the processing requirements, third one is the bandwidth requirements, that is MRs and PRs and BRs. There are three types of disadvantages while you are discussing with link state routing algorithm. The first one is the memory requirement. The link state routing protocol creates and maintains a database and SPF tree. The database and SPF tree required more memory than if you are comparatively discuss with distance vector routing protocol or the algorithm. Here, the link state routing, that means the LSPFs creates and maintains a database and SPF tree. Tree means, suppose it is like that only, having the three nodes, again it will be having the sub nodes. So this is called the tree. In computer networks, it will follows the hierarchy. It will follows the hierarchy. Hence, the database and SPF tree required more memory if you are comparatively discuss or deals with the distance vector routing algorithm. Coming to that processing requirements, the first one is the memory requirements, which is associated, maintains a database along with the SPF tree. A tree is a hierarchical architecture maintaining the database and explores the hierarchical information from a root node to the second level of nodes and the third level of subnodes. Coming to this, the processing requirements, the LSPs or the link state routing protocols also require more CPU processing because the SPF algorithm requires more CPU time than comparatively with the distance vector algorithm, like the Bellman-Ford or link state protocols build a complete map of the topology. So when you are comparatively thinking, the processing requirements means it requires more CPU time. The link state routing algorithm requires the processing time is more and the intake of bandwidth, like the intake of memory requirement is less and the processing time is more. Hence, when you are comparatively thinking based on the Bellman-Ford algorithm or the link state routing algorithm, it builds a complete map of the topology. Hence, if you can able to discuss based on the processing requirements comparatively with the distance vector routing algorithm, it is having a requires more CPU time to process the packets which are associated with the one subnets while transmitting from one router to the another node, from one node to the another node. Coming to the bandwidth requirements, the link state routing protocol floods the link state packet during initial startup and also at the event like network breakdown as well as and the network topology changes, which affects the available bandwidth on a network. If the network is not stable, it also creates issues. It also creates the issues on the bandwidth of the network. Bandwidth means BPS. That means the rate of bits or the rate of data packets which can able to transmit per second, bits per second. Here, the link state routing protocol floods link state packet during initial startup and also at the event like network breakdown and the network topology changes, which can affect the available bandwidth on a network. If the network is not stable, it is also created issues on the bandwidth of the network. This is mainly associated with the bandwidth requirements. That means it is not only related with the initial startup and at the ending of a destination reach up, not by means of initial startup and ending by means of a destination reach up. It is also associated with the events like network breakdown. Network breakdown means when there is a errors or any packets will be discarded, and that is nothing but the flow of the data packets or the bits, it will be discarded. Hence, that system, what we can call it as a network breakdown. While transmitting the data packets or the data bits from one node to the another node, if there is any error, corruption or any discarded of the packets, it will be occurring. That situation, what we can call it as a network breakdown. And network topology will be changes. Why? Because that packet will transmits to the sender again and rechecks it by means of some checksum technologies or error redundancy or error detecting techniques. Again, we need to retransmit that packet to its concerned destination by means of that same sender or a source router. So, which affects the available bandwidth on a network. Hence, if those things will be happening or causing while when the network is flowing in a good way, or if you can imagine while flowing the data packets on a one network in a good way, if there is any disturbance or any disruption or any error, corruption or any packets will be distorted, the total network will be breakdown. Hence, there should be a change. It will be occurring parallelly by means of a network topology. So, hence, the bandwidth is very, very important requirement to transmit one data packet or one data frame on by means of a one network to reach its destination from one node to the another node. This is the main disadvantages. What are the main disadvantages? Memory requirements as well as the processing requirements as well as the bandwidth requirements. Again, I want to recollect or make the review of what is meant by the link state routing according to this current video. And again, I want to discuss what do you mean by the link state routing and what is its definition. A routing algorithm which directly follows for creating the least cost path or a shortest cost path out of all network topology or the nodes which will be associated on one subnet. The nodes which will be associated on one subnet, we need to define or determine the least cost path or shortest path So this is the main definition which shall be included under while you are discussing with link state routing protocol. And forwarding tables, what we can call it as a link state. The tables which are associated with the link state routing algorithm, what we can call it as a link state. That means LS routing. And here the method uses the term link state to define the characteristic of a link. Each link figure associated by means what we can call it as a edge. The link in between one node to the another node. What we can call it as an edge. The link is what we can call it as a edge which can represent the network under the total internet of subnets or internet of topology. And what is the main theme involved while you are working with link state routing or disject algorithm is preferably it is worked on the lowest cost path to links with higher cost. If the cost of a link is infinity, it means that the link does not exist or it has been broken down while in the middle of at any time. This is the main concept which should be included by means of a link state routing algorithm. So coming to this, and what are the two phases? Again, the reliable flooding initial stage as well as the final stage. And at the end of this video, the students can able to learn what do you mean by link state routing algorithm and what is its use if you have worked on this link state routing or the disject algorithm. What are the two phases which shall be included under by means of a link state routing algorithm, what you can call it as the initial stage as well as the final stage, and how the link state routing is approximately it is how it is useful to calculate the least path or a shortest path from one node to the another node. And if you can, the link state routing algorithm is also known as disject algorithm, which is used to find the shortest path from one node to every node of all the total network. And hence the link state routing is also called as iterative, and out of many iterations at finally we need to determine what is the least cost path or the shortest cost path. So out of after that one, and how to calculate the least path from one node to the another node. If you are taking from root node to the subnode B, from root node to the subnode D, after that one, that B node to the C, these C, E and F already extended nodes from the B and D, and from B to the C, from D to the E, and from C to the E, and C to the F, and E to the F. So these are all not directly the roots which are associated from the root nodes, and whatever the roots, those are linked means B and D only. C, E and F which are extended from B to C and D to E. How we can able to associated the links from root node to the another nodes, and how we can able to calculate the least cost path or shortest path by means of a disject algorithm, or what we can dealing currently link state routing algorithm by means of a given some equations, and after that and from one node to the another node, how we can able to calculate the path, the least cost path by means of a one given formula, and which that formula is known as a disject formula. And after that one, the advantages of the link state routing algorithm, what we can call it as a, mainly the advantages what we have already discussed. Based on that one, mainly what are the advantages? Fast network convergence and topological map, as well as the hierarchical design and the event drive messages. So the LSP contains all the information about the subnet where it is associated already. So coming to that, the disadvantages of the link state routing algorithm, mainly the memory requirements as well as the processing requirements as well as the bandwidth requirements. So this is the main useful greedy algorithm which is identified and useful to find the least cost path or the shortest path from one node to the another node by means of giving this formula, what we can call it as, to identify or to calculate the nodes from A to C, that D of B is equal to minimum D of C of D of D and plus D of C. So if you can take it in an additional way, minimum 5, the path is 5, hence 1 plus 3 is equal to 4. So if you want to take the path from A to C according to this equation, and the path is 4. So like that only, if you want to take from, according to the given example, A to B, the minimum path is 2. And according to this, if you want to calculate A to F, the minimum path is 4. So like that only, we can able to calculate the very least cost path or the shortest path from one node to the another node while you are working with link state routing or disject algorithm. And I hope this video is very much useful to the students. And thank you one and all. Keep watching to my upcoming video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.